Hi everyone, my name is Shaurya Pratap Chauhan, a second year Btech CSE student at Bennett University. Today I am going to explain you the counting sort algorithm. So let's get started. Let's just say as an example, we are trying to sort this array into an ascending order, and counting sort works best when the range of numbers each value could have is very small in the array. So let's say the range of values that we could have for each item is 0, 1, 2, and 3. The first part of applying counting sort is going to be finding the starting index for each number, and is going to be clear what I mean by that in a second. So the first step for doing that is going to be counting the number of occurrences for each number in the array. So, for example, there's only one occurrences of 0. So I am going to write down 1 here. Next, 1. So there are 3 occurrences of 1. 1, 2, and 3. So I'm going to write down 3. Similarly, there are 0 occurrences of 2, and lastly there are 2 occurrences of 3. So we can store these numbers in an array of length 4. Once we have these number of occurrences for each number, the second step is going to be adding each number to the right of it accumulatively. What I mean by that is the first number at the index 0 stays the same. The second number will be 1 plus 3, which becomes 4. Now 4 plus 0, it becomes 4. And finally 4 plus 2, it becomes 6. After that step, we have the numbers 1, 4, 4, and 6 for the numbers 0, 1, 2, and 3. The next step is going to be shifting this whole array to the right by one cell. And we are going to do that by looking at this array from right to left. So we are going to first start with the last index, which in case here is index 3. So first of all, here the last index is index 3. So for the index 3, we're gonna put index 2 value, that is 4, into index 3. So index 3 now has 4. Now after that, we're going to put the value in index 2, which is currently in index 1. So now we have to put it like this, and now index 2 has the value which is currently stored in index 1, and it's now 4. Similarly, we're going to put 1 in index 1, and index 0 is gonna be 0. And these numbers 0, 1, 4, 4 are actually the starting index for the range of numbers we have in this particular case, that is 0, 1, 2, and 3. And here's one way to think about it. If you look at number 3 or index 3, you will see the corresponding number or corresponding index is 4. Well, this is because when we sort this array, the number 3 will start at the index 4. Another way to think about it is that there are 4 items that should appear before the number 3 in the sorted array. And that should be obvious. If you just look at the first array that we constructed, there's one occurrence of 0, there's 3 occurrences of 1, and 0 occurrences of 2. So adding them up, we get 4 items that should appear before the number 3, and that's why the starting index of number 3 is 4. Once we have the starting index for each number, the rest is relatively easy. We are going to first initialize a new array whose length will be same as the original array, which in this case is 6. And then we are going to iterate it through the original array one by one. When we are looking at the first element of this array, which is 1, we are going to check what the starting index for this number from the array that we constructed. We see that the starting index is 1, so we are going to put this number in index 1 of new array. And then we are going to increment our starting index by 1 and it becomes 2. This is so that when we look at the second instance of the number 1, we'll know that it should be going to index 2 instead of 1. And then we are going to increment it again. We'll do the same thing for each element of this array until we get from left to right to the last number. Well, now you might have noticed that this process makes counting sort a stable algorithm. What that means is that, of course, if you look at different instances of the same value, for example, the number 1, the order in which they appear in the new sorted array is exactly the same as the order in which they appear in the original array. And this wouldn't matter if there were just number 1, but if they represented underlying meanings to them. For example, if there were ages of three different people, let's say Ram, Sham, and Jay, then we might care if they appear in the same order or in a different order if in this sorted array as the original unsorted array. Now let's quickly go through a few important properties of the counting sort. First of all, as I mentioned before, it's a stable sorting algorithm. Secondly, the time complexity for this algorithm is big O of n plus k, where n is the number of elements that we have in the original array and k is the range of numbers that we could have for each element in the array. And finally, the auxiliary space complexity is big O of n plus k for counting sort. This is because we need to create an entirely new array with length n and of the same size as the original array, as well as an array of length k to keep the track of the starting index for each number. So now I can assume that you must have understood the counting sort algorithm completely. Thank you.